Hello students, I've had some questions about the second part of this problem on your homework, so I wanted to go through it quickly with you. So in class, both last Wednesday before Thanksgiving and then also today, we looked at Taylor series and Taylor polynomials. And so today we spent a lot of time going over Taylor polynomials. And so what I've done is actually part A. I've pre-done part A for you. And you would be able to do this using the techniques we learned in class today. So let's say we developed the third degree Taylor polynomial, okay, and it came out to be t of x equals, and then as I've written here, 10 plus 1/4 times x minus 5 minus 1 over 320 x minus 5 squared plus 1 over 12,800 times x minus 5 to the third power. So suppose this is our Taylor polynomial of the third degree, which is an approximation for our original function. And our original function was just the square root of 5x plus 75. And so this series here represents, this polynomial function represents an approximation for the square root of 5x plus 75. Now, we are specifically asked to use this Taylor series approximation, or this Taylor polynomial, to approximate 110, or the square root of 110. And how do we do that? Well, let's see. We're starting off here with the square root of 5x plus 75, and we want that to be 110. So our first job, very first here at the very first thing, is to figure out what value of x could we substitute into this expression right here, square root 5x plus 75, to give us 110. So that's the first question. What value would we have to put in place of x in order to get 110 under the square root? Well, let's see. That's just a quick equation, right? 100, whoa, did that one wrong. So 110 equals 5x plus 75. Solve that simple equation, right, by subtracting 75 from both sides. And I think that's going to give us 35 equals 5x. And then continuing to solve for x, we're going to divide both sides by 5. And so it looks like to me that if we let x equal 7, that's going to give us 110 under our square root. Now, how does that help us? Well, let's see. So again, the Taylor polynomial right here on the left side, and I'll write it out, our Taylor polynomial t of x equals 10 plus 1/4 times x minus 5 minus 1 over 320 times x minus 5 squared plus 1 over 12,800 times x minus 5 cubed. This is our approximation for this function, 5x, square root of 5x plus 75. And this x here on the right side is the same x over here as on the left side, right? The Taylor polynomial of this x equals square root of 5x plus 75, or is approximately equal to the square root of 5x plus 75. So do you see what I'm getting at here, right? So if that x on the left in that Taylor polynomial matches that x on the right in that square root, if we have discovered that when x is 7, it gives us 110 under the square root, well then that means to just get the approximation, we have to plug 7 in for x on the left side. So really, to get your answer, you're just going to take, and everywhere you see an x, you're going to replace it with that value 7. But we're going to do it on our approximation side. So you're going to plug into a calculator, or, if you like, into WeBWorK, this value right here. You're going to take our Taylor polynomial, but in place of x, you'll put 7 because 7 gives us 110 under the square root for our original function. And this value right here, let's see. If you were to actually go and put it into a calculator, like Desmos, you would find that that's equal to 10.488125. Yep, 10.488125. And that's what you can put in your answer. 10.488125. And that is an approximation for the square root of 110 using the third degree Taylor polynomial. I hope this makes sense. If you have any questions at all, just give a holler and email. Okay, thanks.